In this lecture, we are going to look into a single server key value store. So now we are going to see a scenario where we implement this key value store, like we save the key value pair in a case of a single server. So suppose I have a single server which has its own memory and which has its own disk space. Suppose the disk space is currently approx 100 GB. Now suppose a client wants to write its data in form of key value pair into this server. And another thing is like this memory space might have some cache into it. So what eventually happens is when the client tries to write this key value pair, the logic is implemented in such a way that it initially stores this key value pair inside a cache, and now there are a large number of key value pairs are being pushed by the client into this server. So when the cache is full, it pushes this data to the disk space. Suppose this data which is being pushed into this server node exceeds 100 GB. What can we do in that case? What we can do is, immediate thinking is like, we increase the disk space. We make it 200 GB or rather 1 TB. Now suppose this data is greater than 1 TB. What do we do in that case? By the way, to mention, this method of increasing the disk space is called vertical scaling. This is vertical scaling, this kind of. Now suppose this is 1 terabyte of data, greater than 1 terabyte of data. So there is always a limitation into how much we can increase the disk space. We can't increase the disk space as we want, like how much data is being influxed and we increase the disk space like that, because we might eventually reach into the disk space of supercomputers, and it's rather not possible for every organization to afford such huge amount of disk space or huge cost. So what can be done in this situation? So the problem is, which we are facing currently, is we have a huge amount of data in key value pair, and we have disk space whose size is less than this data size. So can you think of a solution, probable solution, what can be done in this case? So pause the video, and if you want, you can give it a thought, and I hope you have given it a thought. Now I'll continue with the solution. So immediate thought which comes to our mind, why not increase the number of servers? So like initially, suppose I have 100 GB disk space, server 1. I'll make it up to say server 2, which is also 100 GB, server 3, and like that we make n number of servers, which is 100 GB. And suppose I have key value pair and the total size is 1000 GB. What we do is we divide this into 50 GB of 20 chunks and store each 50 GB inside this server nodes. And thus we are able to store this huge amount of data in a couple of number of server nodes. So if you look into this, what we did is, firstly, we increased the number of server nodes. This, by the way, is called kind of horizontal scaling. The size although was same for each server node, we did not increase the disk space. If you see, here also it was 100 GB and here also it is 100 GB. But what we did is we did not increase the size. And the second thing what we did is to fit the data into this server nodes, we partitioned this data into 20 chunks of 50 GB each. This can be anything, but for example, I am considering this is what we have done. So here also we did another thing which is called data partitioning. So these two things which we see, data partitioning, distributing the data into multiple server nodes, maintaining consistency, increasing the number of server nodes to accumulate this huge amount of data. This funda or this logic which we see here is called nothing but distributed key value store. So now we will deep dive into what is this distributed key value store. So as the name suggests, the key value pair is being distributed into a number of servers. So this is a high level picture. We will now deep dive into each and individual component, how these things work, how is the data being partitioned, how is the data being stored into individual server nodes, is it stored into a single server node only, or the data is being replicated to multiple server nodes, how we handle the consistency, how we handle the availability. All these things we will be discussing eventually. So now let's look into in detail what is this distributed key value store and how do we achieve a distributed key value store with consistency, availability, and everything in place.